We just talked about a situation where I simply drop an object. And when I drop an object, our initial velocity is 0. Take a look, it's not moving at all. And our final velocity is some negative value, because it's downwards. That's because acceleration due to gravity on Earth is negative 9.81 meters per second squared. We want to use that value. Implicit in this is that we are defining downwards as negative. If we define downwards as negative, it means we're defining upwards as positive. And that's going to affect our values when we add initial velocity to the expression. For example, if I throw an object downwards, well, it has an initial velocity, and that initial velocity would be negative. Like if I said I throw an object downwards with an initial velocity of 10 meters per second, the value you would use for your equation in your known and unknown chart is that the initial velocity is negative 10 meters per second. It's negative 10 meters per second in that scenario because I threw it downwards. So if you throw an object downwards, you want to say, well, that initial velocity is negative because I made negative downwards. And I have negative 9.81 meters per second squared as my acceleration, which is also downwards. Now let's look at a different scenario. What if I throw an object upwards? What will be true about the initial velocity in that scenario? Well, our initial velocity, if we throw an object upwards, is going to be positive because I'm making up positive. And we have a couple of things that we know here when we throw an object upwards. First of all, your initial velocity, if you throw an object upwards, is going to be a positive value. Like for example here, a ball is thrown upwards with an initial velocity of 19.62 meters per second. We make a known and unknown chart here, and that value for initial velocity would be positive 19.62 meters per second. We have a positive value there. Second thing we know here, you throw an object upwards, it reaches a peak height. It makes sort of a parabola and reaches a peak height. At peak, we know another value. At peak, we know our final velocity is 0. The object will turn around in the air and start to move downwards. So if you throw something upwards, at peak, your final velocity is 0 meters per second. This is going to be very important. At peak, your final velocity is 0 meters per second, because I throw it upwards and kind of stops in the air for an instant before it comes back downwards. The velocity goes from upwards and positive to downwards and negative. And right here, it's at peak when the velocity is 0 meters per second. That brings us to a couple of different scenarios that I want to take a look at now. Let's look at this particular problem that I just wrote on the board. We have here an initial velocity of 19.62. We said that. Great. Other things we know here. Well, the object was thrown upwards. We're on Earth, so our acceleration is going to be gravity, which we're going to use negative 9.81 meters per second squared. Now we have a question like, how high will the ball travel? Well, we have another thing we know here. At the peak, how high will the ball travel? We know VF is 0 meters per second. We know VF is 0 meters per second. And how high will it travel? Well, that's displacement. So you could say, well, height here is the same as displacement when the final velocity is 0. What equation uses 1, 2, 3, all of these values here? VF squared equals VI squared plus 2AD. And you could solve that and you would find your displacement. And now this gets a little bit more complicated than the ones that we have worked with so far. But if we take a look at what this actually winds up looking like here, and I certainly want to make sure that it's working out, we have our VF squared, which is going to be 0, so who cares? It's going to be equal to our VI squared, which is 19.62 meters per second, and we're squaring that, plus 2AD plus 2 times negative 9.81 meters per second squared times our displacement. And we can kind of work that out. We subtract this to the other side. 19.62 times 19.62 is going to be equal to just some crazy number, 1,346. We subtract that to the side, so it's negative, is equal to 2 times negative 9.81 times d. We're going to divide that by 2. We're going to divide that by 9.81. And we should get a height of 68.62 meters. And that would answer, how high will the ball travel? The ball will travel to a height of 68.62 meters. We can answer other questions here with that implied unknown of final velocity of 0. If we know that it reaches a certain height, and at that height, we're going to say our final velocity is 0. What else can we solve for here? Well, we could solve for how long it will take to reach that height. Let's take a look at that scenario, how long it will take to reach that height. So let's look now, we're trying to solve for how long it will take, and that's going to be time. So how do we find time? VI, A, VF, T. What equation do we use? VF equals VI plus AT. And we substitute in. 0 is our VF at peak height. We're talking about when it reaches the peak height. Equals 19.62 meters per second plus negative 9.81 meters per second squared times time. Subtract this, 19.62 equals negative 9.81 times time, divide by 9.81, and you should get a time of 2 seconds. This object will take 2 seconds to reach its peak height. And that brings us to one last known unknown. We already know that if an object is thrown upwards, the VI is positive. We know at peak, the VF is 0. We just found the time upwards is 2 seconds. Here's our last thing that we know here. How long will it spend in the air in total when you're dealing with a projectile? And that's where we're actually starting here. When you throw an object upwards and it comes downwards, the time up is equal to the time down. So if this took 2 seconds to go up, it'll take 2 seconds to go down. So how long will it spend in the air in total? Double the time up, which is 4 seconds, because the time it took to reach that height was 2 seconds. And we can find that using that known unknown, that final velocity at peak is 0. But of course, you could actually find any value at any time. For example, what is its height after 1 second? Well, you could say, oh, after 1 second, it hasn't reached the peak. So the final velocity is no longer 0. But now, I move time into my knowns. And our time is 1 second, and I want to know how high it'll reach with the displacement. So you could find it really at any point during this journey, if they give you, let's say, the time at that point. So let's try that out. VI, A, time, displacement, we know D equals VIT plus 1/2 AT squared. And we can use that to find our final height. And we can say, well, our height is our displacement, so we don't know that. Okay. Our initial velocity now is 19.62 meters per second. Our time is 1 second plus 1/2 times negative 9.81 meters per second squared times, again, 1 second squared. And we should get here, let's take a look at what happens. We get 19.62 meters, because seconds cancels out here. And now it's plus 1/2 times negative 9.81. So we're going to do 1/2 times negative 9.81. We get negative 4.905 times 1 squared. So you get 19.62 minus 4.905. Because 1/2 times, when you multiply all this, you get negative 4.905. 19.62 minus 4.905, you should get a displacement of 14.7 meters. Notice how important the signs were here. The negative sign on this acceleration told you acceleration was downwards. The positive sign on this initial velocity told you that velocity was upwards. And it's important that we match up with the positive and negative signs that we set at the beginning of the problem. I want you to make down negative, upwards positive. It's important we stick to those because it's going to set up our math here. Subtracting here was critical. If you didn't subtract, if you didn't realize that's a negative sign and work it out correctly, you would have gotten this problem wrong. And if you were like trying to land a space shuttle or something or launch a rocket, you probably would have hurt a lot of innocent people. These are some of the new known unknowns. If you throw something upwards, VI is positive. At peak, VF is 0. Time up equals time down. If you throw something downwards, initial velocity is negative. And that does it for throwing stuff upwards and downwards. And we'll take it from there.